We need to do structural testing because it's essential that we know the stiffness, strength, and ductility of structures. What makes it challenging to determine these quantities is the nonlinear characteristics of materials. For example, you see behind me some tests that have been done on reinforced concrete and masonry structures. When they are loaded, for example, the concrete is loaded, the concrete cracks, reinforcement bars stretch. These are actually fairly complex and difficult phenomena. Through our structural testing, we get a full understanding of the response of structural components to loading, and we're able to characterize its stiffness, strength, and ductility. Now let me go through and describe what stiffness, strength, and ductility means. You were probably introduced to the idea of stiffness in high school and introduced to Hooke's law, that the force is proportional to the deformation. And so the force to stretch it 2 inches is going to be twice the force to stretch it 1 inch. And that's true for things such as springs, things that are in this linear elastic aspect of the response. But as just mentioned, a lot of the structures that we design in practice are utilizing materials that don't have that characteristic. Stiffness is how much loading it takes to get a structure to deform a certain amount. The larger the structure, typically the greater the stiffness. Steel structures are stiffer in general than concrete structures for components of the same measure. We also care about the strength of components of structures, and the only way to properly assess what those strengths will be is to do a load test. And so, for example, if I take this styrofoam, I will load it until it hits its capacity. We do tests on structural concrete, structural steel, and in those tests, we take the components of structures to their breaking point. The third and final thing we care about greatly is ductility. For the styrofoam beam that I just broke, we wouldn't want structures to behave in that way. We wouldn't want a structure, once it got to the maximum capacity it could carry, to suddenly break, but we want it to be able to continue to hold that load through a large amount of deformation so that we would recognize there was a problem with the structure and go in and do whatever kind of repair was needed. One of the common types of structural materials that we use is steel. Steel has a very nice ductile response. You know that as you load the steel, it'll eventually get to a point where it's starting to give, and even as it's giving, is continuing to hold a lot of load through that deformation.